Salutations, mini mathematicians. Thank you so much for being here. We're going to be going over 5.1c lesson today, more exponent rules. So our purpose is to learn 3 more rules from the 2 that we learned last time. So the first rule we're going to be learning is called power of a power. And this always makes me think of Mario when he gets the mushroom, he goes bloop, 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 and like multiplies and gets bigger. So here we have x cubed to the second power. Well, look up high your exponents how many times you multiply. So this means I need 2 factors or 2 x to the thirds being multiplied together. Well, we know when you're multiplying with the same base, you add your exponents, so we get x to the 6th. Another thing we can think about is 3 times 2. So whenever you have a power to a power, you're really just multiplying those exponents and keeping the base the same. So we'll write when you have an exponent raised to another exponent, multiply the exponents and keep the base. Algebraically, that's x to the a to the b power is equal to x to the ab power. If we looked at this with numbers, x to the 5th to the 3rd power is x to the 5 times 3 power, which is x to the 15th. So we just want to think about the product or how many total factors you have of x. If you have 3 groups of 5 factors, you have 15 factors of x. Perfect. And if you need to pause the video to finish writing that down, please do so. We're going to look at the second rule we're going to be learning today. So the second rule we're going to be learning is called power of a product. So it's a power or an exponent raised to a product. So here, very similar to power of a power rule, if we have an exponent of 2, look up high that exponent's how many times you multiply. We're multiplying 3x squared by itself 2 times. So 3x squared times 3x squared. Well, that means it's 3 times 3 times x squared times x squared. When you multiply something by itself twice, that's being squared. So 3 squared times x squared squared, which gives me 9x to the 4th. So from the very beginning, I could have skipped all this expanding work and just said, well, this exponent on the outside, if you're multiplying everything on the inside, belongs to each factor. So 3 squared, which is 9, and x squared squared, which is x to the 4th. So when you have only multiplication inside the parentheses and an exponent on the outside, the exponent belongs to each factor inside. So ab to the x, notice that's being multiplied inside, gets me a to the x, b to the x. 5x to the 4th all to the second is 5 to the second, x to the 4th to the second, so 25x to the 8th. Nice work. And now let's talk about our last rule we're going to be learning, which is power of a quotient. So again, very similar to power of a power. Power of a quotient says if you are only dividing, and you have an exponent on the outside, that exponent on the outside belongs to every factor on the inside. So if you have 5x cubed divided by 2y to the 4th, 2 times. Then if I expand this out, I'd have 5 times 5, x cubed times x cubed, 2 times 2, y to the 4th times y to the 4th, which of course is just 5 squared times x cubed squared times 2 squared times y to the 4th being squared. So that gets me 5 squared is 25, x to the 3rd squared is x to the 6th, 2 squared is 4, and y to the 4th squared is y to the 8th. So our words are when you have only division inside the parentheses and an exponent on the outside, the exponent belongs to each factor on the top and the bottom. A over b to the x power is a to the x power over b to the x power. 2y over 5x to the 3rd all to the 3rd power. 2 to the 3rd power is 8. Y to the 3rd power is y to the 3. 5 to the 3rd power is 125. And x cubed to the 3rd power is x to the 9th. Great job. Now that we have our lesson purpose written down and we have an idea about these rules, let's investigate them a little bit farther. Please make sure you have your calculator handy so we can go over these quickly. Okay, so the first question says, what does 2 to the 3rd to the 4th power simplify? Choose all that apply and explain your reasoning. Well, 2 to the 3rd to the 4th power means there's 4 factors of 2 to the 3rd. So that's 2 to the 3rd times 2 to the 3rd times 2 to the 3rd times 2 to the 3rd. And we learned last class that if you're multiplying with the same base, you add your exponents. So that would get you 2 to the 3 plus 3 plus 3 plus 3, or 4 groups of 3 is 12. So 2 to the 12th. So let's grab our calculator and figure out what 2 to the 12th is. 2 raised to the 12th power is 4,096. Okay, well, let's take a look. Well, this is 4 to the 4th times 2 to the 4th. Well, 4 to the 4th is 256. And 2 to the 4th is 16. 16 times 256, oh, gets us the same thing, 4,096. Really cool. And the reason this is true is because I can rewrite 4 as 2 to the 2nd power, which is 4, to the 4th power, times 2 to the 4th power. And power to a power, this gets you 2 to the 8th, 2 times 4 is 8, times 2 to the 4th. Multiplying with the same base, you'd have 8 factors of 2. Here you'd have 4 factors of 2 for a total of 12 factors of 2. Well, 2 to the 7th. 2 to the 7th is not going to be 2 to the 12th, so we don't even have to put that in our calculator. Let's look at the next one. 6 to the 4th power. Well, 6 to the 4th power is 1,296, so that's also not equal. 4,096, well, that is equal. We already showed our work there. And then, 2 to the 12th, that's also equal. We'll just draw an arrow to our work. And 16 to the 3rd, well, let's grab our calculator. 16 and then that caret button, and then our exponent is 3, is also 4,096. And it's 4,096 because if I look at 16, if you look at 16 and you make a quick factor tree, 16 is 4 times 4, which is 2 times 2 times 2 times 2. So I know I can rewrite 16 as 2 to the 4th power. So that means I can rewrite this as 2 to the 4th power to the 3rd power. All I'm doing is replacing 16 with 2 to the 4th, and power to a power says if I have 4 factors of 2 and I have 3 groups of it, well, that's going to give me 12 factors of 2. Yay! So F is also correct. So how do we find power of a power without expanding? Without expanding, we multiply the exponents. So the algebraic rule for power of a power says that x to the a power, all raised to the b power, is x to the a b power, because a times b is just next to each other. So we're going to skip number 4, and we're going to jump into some practice on the next page. So we're going to do a couple problems together, and you're going to do some on your own after we pause the video. So again, power to a power, I'm just going to write the rule up here. X to the a raised to the b power is x to the a times b power. And that's just going to help me remember these. So let's take a look. This is x to the 2nd power all to the 3rd power. So our shortcut says you just multiply the exponents. X to the 6th. If you're not comfortable with that shortcut, you can think of expanding that this is x squared 3 times, which gets you 2, 4, 6 x's, x to the 6th. Nice work. If we look at the next one, a to the 4th to the 2nd, well, you have 4 factors of a and you have 2 groups, so multiply. I like to put a little dot there. Parentheses usually mean multiply. That's right, a to the 8th. 4 times 2 is 8. So we're going to skip 7 and 8 for now. Let's move on to 9. Ooh, so this is power of a power of a power. So it's the same rule that we're going to multiply. So let's think about this. I'm going to go c to the 5th to the 6th power. We're going to multiply that. So you'd have 5 factors of c 6 times to have a total of 30 factors of c. And that's being raised to the 7th power. So you'd have 30 factors of c, c times c times c times c 30 times, and I'd have to multiply that 7 times, right? So 30 times 7 gets you 210. So that's c to the 210th power. Wow, I'm so happy I don't have to expand that out. I'm so happy for this rule. Okay, let's look at 11 and 12. 11 is y times y to the second to the second. Remember that sneaky silent exponent of 1 here. Is there anything else I can simplify? Well, here's power of a power. So I get y to the first times y to the fourth. And now we're combining our rule from last time, where if we have 1 factor of y and 4 factors of y, we're going to have a total of 5 factors of y. Nice job. Let's look at 12 one more time together, our last problem on this page. And we have d to the 8th times d to the 10th to the 3rd. So again, this is power of a power. So I'm just going to bring down this d to the 8th times this turns into 10 factors of d, 3 groups. So that's 30 factors of d. 10 times 3 is 30. And now if you have 8 factors of d and then another 30 factors of d, you're going to have a total of, that's right, 38 factors of d. Perfect. Go ahead and finish 7, 8, 10, and 13, finishing those problems, and we're going to go over them as soon as you're ready. So go ahead and pause the video, and we're going to go over 7, 8, 10, and 13. Okay, taking a look at number 7, we end up with b cubed to the cube, power of a power makes this b to the 9th. If I look at number 8, I have a to the 3rd all to the 5th power, which is a to the 3 times 5, which is a to the 15th. And let's show this step in the middle. It can be really helpful when we learn more rules. Number 10, x to the n power all to the second. Well, n times 2 is just 2n. Very good. 2 times n is 2n. X to the 2n power. And our last one we had to look at, number 13, we had r to the 3rd to the second, power of a power. I multiply 3 times 2 to get 6. And it's times r to the 4th, which means I need to add my exponents here to get r to the 10th power. Nice work, mini mathematicians. Let's keep looking at some more rules. So if we wanted to compare with a less than, greater than, or equal to symbol, let's see if we can simplify this. Remember, our sneaky silent exponent here is 1. We're multiplying with the same base, so we add our exponents, or you can think about this as x times 1, 2, 3, 4 x's, which gets you x to the 5th. So if we're comparing x to the 5th and x to the 5th, well, these are going to be equal to each other. If we look at the other one, this is a to the second to the 6th, so that's power of a power. So we multiply, and 2 times 6 gets you 12. Very nice. But over here, this is a to the second times a to the 6th, so that's only 2 factors of a, and then 6 factors of a to get you a total. It's a to the second plus 6 gets you a to the 8th power. So we're comparing a to the 8th and a to the 12th. So a to the 12th is going to be greater than a to the 8th. Nice job. So let's investigate another set of numbers to see our next rule, our second rule of this lesson. So we want to know, what does 4a to the 3rd all to the second power equal? So this is, again, power of a power, but just a little different because everything is being multiplied on the inside. So over to the side, 4a to the cube to the second power means we're going to have this factor 2 times. So that's 4a to the 3rd times 4a to the 3rd. Well, if we organize our factors here, that's going to be 4 times 4 and a cubed times a cubed. Well, 4 times 4, that's just 4 squared. And a cubed times a cubed is just a cubed squared. Oh, so that exponent on the outside belongs to each factor on the inside. 4 squared is 16, and a cubed squared, 3 times 2, is 6. So a to the 6, 16, a to the 6. So let's see which ones we have that are the same. Well, c is the same, and that's it. None of these other ones are the same. So some common mistakes I see is they see the 4 and the 2 and they multiply to make 8. We don't do that with exponents. Look up high the exponents, how many times you multiply your base. 4 times 4 is 16, not 8. The other mistake they did is they added their exponents here, but remember, power of a power is how many groups you have, which you need to multiply. Again, here they got the coefficient right, but not the exponent. And here they got the exponent right, but not the coefficient. Okay, let's keep going. So this explains our next rule, which is power of a product. So we're going to explain how to find power product without expanding, and we're going to use an example to justify our explanation. So we're going to say apply the exponent to each factor inside. And my example is going to be 2x to the fourth to the third power. And we're going to show that that's 2 to the third times x to the fourth to the third. Sometimes I'll circle the 3 and I'll draw an arrow to each factor. And 2 to the third, if you don't know, you can always grab a calculator. 2 times 2 times 2. 2 times 2 is 4 times 2 again is 8. And x to the 4 times 3, power of a power, that little parentheses mean to multiply, x to the 12. So the algebraic rule for, again, this is called power of a product because it's an exponent or a power on the outside of a product. The product is on the inside. Everything's being multiplied. States as AB all to the x power is a to the x power, b to the x power. Nice job. So let's take a look. We're going to do some examples. I'm going to do some with you, and then you're going to do some on your own. So the first one is 2n to the second power. So here, that exponent on the outside belongs to each factor, so it's 2 to the second times n to the second, which gets you 4n to the second power. Good job. The next one we're going to look at is 3a to the fourth b. Sometimes what can be helpful is to break up what's on the inside into its factors. So 3a to the fourth times b, all to the third power. So this 3 on the outside is going to get applied to each factor. So this can be super helpful as we start to look at more complicated problems. So we have 3 to the third, a to the fourth to the third, and b to the third. So 3 to the third, and again, if you don't remember it, you can always grab your calculator. 3 to the third power is 27. A to the power of a power we multiply, 4 times 3 is 12, and then b to the third. When we're writing these expressions, we want our coefficient in front and then our variables in alphabetical order. Oh, let's look at this next one. I'm definitely going to use my trick of separating out my factors so I don't miss anything. So inside I have 3 to the third times x to the second, and sometimes I'll put y to the first here, z to the second, all to the fourth power. So remember, this fourth power has to be applied to every single exponent. We don't say the word distributed because distribution goes from a number being multiplied to a sum or a difference, but this is numbers only being multiplied. This rule only applies if everything on the inside is being multiplied. So from here, we get 3 to the third to the fourth power, x to the second to the fourth power, y to the first to the fourth power, z to the second to the fourth power. So now we're going to use our power of a power rule. Parentheses mean we multiply. We're going to have 3 to the, you're right, 12th power. X to the, you're right, 8th power. Y to the 4th power, and z to the 8th power. Nice job. Okay, so I want you to finish 19, 21, and 23. So you're going to finish this column, pause the video, finish that column, and we'll go over your answers as soon as you're ready. Okay, let's go ahead and take a look at our work. So ab all to the fifth power is just a to the fifth b to the fifth power. The next one, we have a b to the third 6. So this 6 applies to a to the first, get a to the 6, and then to the b to the third, so b to the 3 times 6, a to the 6, b to the 18th. And the last one you had to do, a little bit trickier, but not too bad if you use our trick of separating out our factors. We have 2 being raised to the third power, y to the second being raised to the third power, and then z being raised to the third power. So 2 to the third is 8, y to the 2 times 3 is 6, and z to the third is z to the third. Perfect. Oh, and a little note I want to make you guys. So 3 to the 12, since we have a calculator, let's simplify that all the way. 3 raised to the 12th power. Oh my goodness, it's a huge number. 531,441, x to the 8th, y to the 4th, z to the 8th. Sneak it in there. Okay. So now what we're going to do is we're going to use our knowledge of exponent properties to think about what x over 5 to the second simplifies to. So here we'd have x over 5 to the second. We know the exponent outside, look up high, your exponent is how many times you multiply. So this would be x over 5 times x over 5. And that would mean it's x times x over 5 times 5. But isn't that just the same thing as x squared over 5 squared? Which gets you x squared over 25. So thinking about this, we can just say that the exponent on the outside is getting applied to each factor on the inside. Again, it's the same rule as power of a power and power of product. It's just now we're applying it to a quotient. So the last rule that we are learning today is the algebraic rule for power of a quotient. For the power of a quotient. Okay, so the algebraic rule for power of a quotient states that any factor on the inside gets that exponent on the outside applied. So a over b, all the x power is a to the x power over b to the x power. Perfect. So we're going to do a few of these together, and then you'll finish the page on your own. So number 27, we have this exponent on the outside. So on the top, I have 5 times x, all being raised to the second power. And the denominator, I have 8 times y, also all being raised to the second power. So from here, I get 5 squared times x squared times 8 squared times y squared. And let's keep simplifying that. 5 squared is 25, 5 times 5, 25x squared, over 8 squared is 64, 64y squared. And we'll circle our final answer. Okay, let's look at 28. So again, I'm going to simplify on the inside first. Simplify on the inside first. And that's going to make it a lot easier. So on the inside here, I have 2 to the second over 1. I have x cubed over x to the first. And I have y squared over 1, all being raised to the second power. So writing it out this way is super helpful. So I can use my quotient of powers that we learned last lesson. So 2 to the second, we know that that's 4 on the top. X to the cubed over x to the first. Remember, we would have 3 factors of x on top, 1 factor of x on the bottom, 1 factor would cancel out, and we're left with 2 factors of x on the top over y squared, all to the second power. So now I have 4 squared, x to the second being squared, and y to the second being squared. So again, I'm applying that exponent on the outside to every factor on the inside, and we're almost done with this problem. 16 x to the fourth, y to the 4th. Great job with that one. Okay, the last one I'm going to do, or the last row, I'm also going to do with you. So let's take a look at 33, 34, and 35. So 33, we're going to again simplify what's on the inside first. So taking a look at what's on the inside, notice all this negative 2 is being raised to the third power. So I'll think about this as negative 2 over 1 and n to the third over n to the first all to the third power. Well, if I simplify what's on the inside, this negative 2 is just going to stay negative 2. I have 3 factors of n on top, 1 factor of n on the bottom. 1 factor will cancel out, and I'll have 2 factors left on top. So now I'm going to have negative 2 to the third power and n squared to the third power. Be careful, because remember, if you have parentheses or not, it's going to change your answer sometimes if you have even exponents. So here, negative 2 all raised to the third power gets you negative 8. And n to the second to the third power of a power we multiply, I get n to the 6th power. Okay, let's look at the next one. So this is going to help me out by thinking about this as over 1. So I have 4n over 1 times this exponent on the outside has to get applied to both of the factors on the inside. So n to the 4 times 2, power of power, and then 4 to the second. So we can think about this as one big fraction with 4 times n times this turns into n to the 8th. And this is over 4 to the second. I can think about this as 4 to the first. So thinking about our quotient property, I have 1 factor of 4 on top. I have 2 factors of 4 on the bottom. 1 factor will cancel out, and I'll be left with 1 factor of 4 on the bottom. Here I have 1 factor of n and another 8 factors of n. When you're multiplying with the same base, you add your exponents. When you're multiplying with the same base, you add your exponents. So I have n to the 9th all over 4. Great job. Okay, let's take a look at the next problem. So the next problem has 3 squared. Excuse me. So the next problem has 3 squared over c and c to the 5th to the 2nd all to the 3rd. So I'm going to leave this 3 to the 2nd over c. I'm going to focus on this exponent of 2 being applied to both of these. So I'll have c to the 5 times 2 and 3 to the 2nd. Now we're going to think about this as one big fraction. I'm going to sort my like bases, because remember, all these rules only work if you have the same base. So here I'm going to have 3 to the 2nd over 3 to the 2nd, and I'll have c to the 5 times 2 is 10 over c to the 1st. Well, with quotient, you have 2 factors of 3 on the top, 2 factors on the bottom. They cancel out to make 1. Here I have 10 factors of c on the top, 1 factor of c on the bottom. 1 factor will cancel out, and I'll be left with 9 factors of c on the top. So my final answer is c to the 9th power. Okay, so you're going to finish up 29, 30, 31, and 32. Go ahead and pause the video. And we will go over them as soon as you're ready. Okay, let's go over and see how you did on these last couple problems. Okay, taking a look at number 29. So I simplified what's on the inside first. So simplifying what's on the inside first, I have 3a to the 5th times a to the 4th. I'm going to add those. It's a product of powers. So I have 5 factors of a, another 4 factors of a, get me 9 factors of a. Then looking at the denominator, I have 10 factors of a down here. So 9 factors are going to cancel out. They cancel out, 10 minus 9, and I get 1 factor of a on the bottom. From here, simplifying what's on the inside, I have 3 over a all to the 5th power. So this power of 5 belongs to the 3 and to the a. And 3 to the 5th power You can grab your calculator for that one for sure. 3 to the fifth power is 243, and it's going to be over a to the fifth. Really nice work on that one. So let's take a look at that last row here that you had to do. So looking at number 30, again, I highly encourage you simplify what's on the inside first and show your work. So here I have a to the second times a to the fourth, which you add your exponents to get a total of a to the sixth. So I brought my a to the eighth down with me, and I left that 5 exponent on the outside. So now I have 6 factors of a on top and 8 factors on the bottom. So we're going to have 6 factors cancel out, and we'll have 2 left over. So we can subtract 8 minus 6 gets you 2. So you have 2 factors of a in the denominator, and it's all being raised to the fifth. So that exponent of 5 belongs to the 1 and to the a to the second. A to the fifth is just 1, and a to the second to the fifth gets you a to the 10th. Power of a power, you multiply. Great job. 2 more left to go over. This next one, there's nothing to simplify on the inside. So it's just this exponent of 3 applying to both of these factors. So x to the fourth, and we're multiplying our exponent. So we get x to the 12th over 4 to the 6th. And yes, because you have a calculator, you do need to simplify that 4 to the 6th to get you 4,096. Last one you had to do, if you simplify what's on the inside first, a over a cancels out to make that fancy 1. You have b over 1, which is just b, all being raised to the fourth power. So b to the fourth is just b to the fourth. So again, showing your work, doing your best, being nice to everyone, and just remembering about those rules. And we're going to be combining those rules. So we have a few more rules to learn next class. So make sure to have these handy. Thank you so much. This again, 5.1c. Do your best, be nice to everyone, and I'll see you next time.